When we look out into the cosmos, there's something undeniably fascinating about the dark expanses of space, the regions where light is trapped, swallowed, and consumed, leaving behind only mysteries. At the heart of many galaxies lie these dark entities, black holes, that have long captivated astronomers and astrophysicists. For decades, scientists have tried to piece together the secrets of these cosmic monsters. But even with all the advances in our understanding, black holes continue to surprise us with their powers, and the latest discoveries are nothing short of extraordinary. Imagine this: scientists have just made a groundbreaking discovery using the James Webb Space Telescope, JWST, that's shaking up everything we thought we knew about black holes and their energy sources. What they've uncovered is a black hole, a monstrous entity, located about 70 million light-years away, whose violent outbursts of gas and dust challenge previous theories about how these cosmic behemoths power their activity. This discovery is not only impressive but also has the potential to rewrite the textbooks on how we understand black holes, galaxies, and the universe itself. Black holes are often called cosmic giants, gravity monsters, or even cosmic eaters. The term black hole might conjure images of an enormous vacuum in space, sucking up everything in sight. While it's true that black holes have the terrifying ability to devour anything that crosses their path, their role in the cosmos is much more nuanced and complex. These incredible entities don't just destroy everything they touch, they also influence the formation and evolution of galaxies, stars, and even the fabric of spacetime itself. To understand the significance of these cosmic beasts, it's important to explore not only how they work but also why they remain one of the biggest mysteries in modern astronomy. One of the most puzzling aspects of black holes is their size. When we talk about a black hole, we're usually referring to something incredibly small but unbelievably dense. For example, a black hole with the mass of our Sun would have a radius of just 2.9 kilometers, far smaller than the Sun's own diameter of nearly 1.4 million kilometers. A black hole with the mass of the Earth would be even more compact, with a diameter of less than 1 centimeter. Despite their small size, black holes exert an immense gravitational pull, one that warps the very fabric of spacetime itself. This pull is so intense that not even light can escape once it crosses the event horizon, the point of no return surrounding the black hole. This leads to one of the most fundamental questions in black hole physics: what happens to the matter that falls into a black hole? The answer to this question is still a matter of intense debate among physicists and astronomers. What we do know is that black holes are not just mindless vacuum cleaners, indiscriminately gobbling up everything in sight. Their behavior is far more complex. Despite their insatiable hunger for matter, black holes can also emit powerful radiation. In fact, some of the brightest objects in the universe are actually the result of black holes. This radiation is not emitted directly by the black hole itself but by the matter that surrounds it, forming what's known as an accretion disk. When matter falls toward a black hole, it doesn't just drop straight in. Instead, it forms a spiraling disk of gas and dust, called an accretion disk, which gets hotter and hotter as it gets closer to the black hole. This heating process can cause the accretion disk to emit radiation across the entire electromagnetic spectrum, from radio waves to X-rays. The energy emitted by these disks can be staggering, so intense that it can outshine entire galaxies. But it doesn't stop there. Black holes can also release powerful jets of energy from their poles, shooting streams of charged particles at nearly the speed of light. These jets can stretch across vast distances, creating spectacular cosmic displays visible across the universe. One of the most fascinating aspects of black holes is their connection to galaxies. It has long been theorized that nearly every large galaxy, including our own Milky Way, harbors a supermassive black hole at its center. These supermassive black holes, often millions or even billions of times the mass of our Sun, are thought to play a critical role in the formation and evolution of galaxies. The gravitational pull of these black holes can influence the orbits of stars and the movement of gas and dust within the galaxy, helping to shape the structure of the entire system. In fact, many scientists believe that black holes and galaxies may be inextricably linked, with the growth of one directly influencing the other. Our own galaxy, the Milky Way, is no exception. At its center lies a supermassive black hole known as Sagittarius A*, which has a mass of about 4 million times that of our Sun. However, despite its massive size, Sagittarius A* is relatively quiet compared to some other supermassive black holes in the universe. It is considered a dormant black hole because it is not actively consuming large amounts of material. Instead, it sits quietly, surrounded by a relatively small amount of matter, consuming only small amounts of gas and dust over vast periods of time. But while it might be dormant, it still exerts a powerful gravitational influence on the stars and gas surrounding it, affecting the entire galactic center. The real fireworks happen when black holes are actively consuming large amounts of material. For instance, the black hole at the center of the galaxy M87, a massive elliptical galaxy located 55 million light-years away, is far more active. This black hole, which has a mass of 6.5 billion times that of our Sun, is surrounded by a vast disk of gas and dust, constantly feeding the black hole with new material. The intense gravitational forces at play create powerful flows of energy, heating up the gas to millions of degrees and causing it to shine brightly across the electromagnetic spectrum. But even more exciting is the discovery that some black holes, like the one in M87, can generate enormous jets of energy that extend far beyond the galaxy's core. These jets shoot charged particles out at nearly the speed of light, creating some of the most spectacular and energetic phenomena in the universe. What makes these cosmic displays so fascinating is the fact that they are powered by the black hole's immense gravitational forces. As gas and dust fall toward the black hole, they get heated up to millions of degrees and begin to emit radiation. But not all of this matter ends up in the black hole. Some of it is funneled toward the poles of the black hole, where it gets accelerated to nearly the speed of light and ejected as powerful jets. These jets can extend millions of light-years from the black hole, creating vast structures known as active galactic nuclei, or AGNs. In some cases, the energy emitted by these AGNs can outshine the combined light of all the stars in the galaxy, making them some of the brightest objects in the universe. However, despite all the incredible discoveries about black holes, one question has remained stubbornly elusive: what powers the energy that fuels these cosmic displays? Traditionally, scientists believed that the energy came directly from the black hole itself. But a recent discovery made by the team behind the James Webb Space Telescope has turned this theory on its head. The JWST has revealed that in some cases, the energy that powers the glowing disks of gas and the jets of material may actually come from shock waves caused by the collision of gas with the jets of a black hole, not directly from the black hole itself. This new finding has opened up a whole new way of thinking about black holes and their role in the universe. Instead of being purely destructive entities, black holes might be more dynamic than we thought, interacting with their environments in complex ways that create shock waves and other energetic phenomena. These shock waves, created by the powerful jets of material ejected from the black hole, may be responsible for heating up the surrounding gas and causing it to emit the radiation that we observe. The James Webb Space Telescope is at the forefront of this revolution in our understanding of black holes. Designed to observe the universe in infrared wavelengths, the JWST is uniquely equipped to peer through the cosmic dust that often obscures our view of distant galaxies and black holes. Infrared light can pass through this dust, allowing the JWST to capture stunning images of the hearts of galaxies and the black holes that reside within them. This has given astronomers unprecedented access to the inner workings of some of the most mysterious and energetic objects in the universe. What makes this discovery even more exciting is the fact that it could help us unlock one of the biggest mysteries in modern astrophysics: the formation and evolution of supermassive black holes. These cosmic giants are believed to play a key role in the formation of galaxies, and yet, we still don't fully understand how they come into being. Some scientists believe that black holes form when massive stars collapse under their own gravity, while others think that they could be the result of the merging of smaller black holes. Whatever the case, the new data from the James Webb Space Telescope could provide crucial clues that will help us piece together the puzzle of black hole formation. But the JWST is not the only telescope that's helping us explore the nature of black holes. The Chandra X-ray Observatory and the ALMA, ATACM, a large millimeter array observatory, are also contributing to our understanding of these cosmic beasts. By using a combination of different wavelengths of light, radio waves, infrared, X-rays, astronomers can study the full spectrum of radiation emitted by black holes and the surrounding gas. This allows them to build a more complete picture of how black holes interact with their environments and how they influence the formation and evolution of galaxies. The latest discoveries about black holes have also led to some unexpected revelations. For example, astronomers recently discovered a transition black hole in the cluster of stars known as IRS-13, located near the supermassive black hole at the center of our galaxy. This intermediate black hole, with a mass of about 30,000 solar masses, is thought to be a crucial step in the formation of supermassive black holes like Sagittarius A star. The discovery of this intermediate black hole could be a game-changer for our understanding of how black holes evolve and how they influence the formation of galaxies over time. So what's next? As technology improves and telescopes like the JWST continue to explore the far reaches of space, it's likely that we'll uncover even more surprises about the nature of black holes and their role in the cosmos. We might discover new types of black holes, new ways they interact with their environments, or even find that they play a far more active role in galaxy formation than we ever imagined. One thing is for sure, the universe is full of secrets, and black holes are at the heart of many of them. Stay tuned, because the next big discovery could be just around the corner. The story of black holes is far from over, and we're only beginning to scratch the surface of the mysteries they hold.